All right, thanks everyone for your feedback on that poll question. Now let's go ahead and get started. Thanks again for joining us today. My name is Heidi Nilsson. I'm a marketing manager at SnapAV, and I'll be the moderator for today's session. Before I turn it over to AHAM, let's go through a few quick housekeeping items. First, we should have some time at the end of the presentation for a Q&A session, so please feel free to send in your questions at any time using the question and answer feature in the webinar control panel, and we'll get to as many of those as we can after the presentation. And lastly, we'll be sending you a follow-up email within the next couple of days that will include a recording of today's presentation. And as a thank you for taking the time to join us, we'll also be including a coupon code for $50 off your next Arachnus Switch purchase. All right, now I'd like to introduce you to today's presenter, AHAM Eric Susi. For those of you who don't already know AHAM, he's the category manager for Arachnus Networks here at SnapAV, and he manages the research and development process for all of our networking products. He has over 10 years of experience in the networking industry and has been with SnapAV for 3 years. Welcome, AHAM.
Thanks, Heidi. Hey, hi guys. Thanks for joining us this afternoon. Could be noontime on the West Coast. It seems like we have quite a bit of dealers or customers on the call. Thanks a lot for your time. Thanks a lot for the poll question answer. It seems like there's a lot of existing Arachnus buyers. 80% of you guys buy our switches. So this should be a two-part session. It's a 60-minute session, so I'll try to go as fast as I can and emphasize on the tips and tricks and technical aspects, and at the end we'll do some introductions and about the new line of switches. So this is our agenda for today. We will talk about network design overall, some general tips and tricks. Then we will talk about VLANs and how you set up VLANs, and we'll do a demo. Then we'll talk about some of the pain points that we've been hearing from the field. We did an in-person training session probably 3 weeks ago in the Northeast, and we saw a lot of feedback about Sonos and URC and some UBIQUITI. And at the end, we'll do the introduction of the new line of switches. So with that being said, we'll start with the network design portion of our session. So we all know that these are the main components of any network setup. So you got a router, you got a switch, and you got a wireless access point. And then you got a bunch of devices connected to those network devices to enable some services. But a lot of time, actually this week, I was telling the guys here in the room that I've been getting more questions about how to set up and how to properly design a network. So how can you put the arrangements of those different devices into a topology that works well for the customer and it's actually scalable and performs well. So we'll talk about just network design in general. And this, in the old days, 7 years ago, this used to be the typical topology that you guys have to deal with from a networking standpoint. You get your internet, then your ISP provider will get you a combo of modem, router, and Wi-Fi, and then you hook up an unmanaged switch and just plug in everything to it and hope for the best. Well, that worked, a while ago, and certainly will not work today or in the future. And that's why you guys are buying more business-grade and more professional-grade gear, because you're seeing a lot more devices coming to the network and a lot more demand to the network. So this design is not scalable. It works for smaller networks. It doesn't future-proof your design or your network, because as you add more wireless devices, your combo modem, router, Wi-Fi that you come from ISP is not designed to handle that much traffic or that amount of clients. It's usually stuck in an attic somewhere or in a structural wiring can somewhere. It's not optimal for Wi-Fi coverage. Plug in everything on a unmanaged switch. While it's cost effective, you will see a decision that is probably not the best way to do it. So how can we design a better network? So this is our recommended topology for mid to large sizes networks, and you can scale it up and down however you want based on the network requirements. So really what you need to do is to think about your network design as a layered approach. So you start with the ISP layer and then goes from that to the gateway layer. This is when you have your router. Then to the core layer, the access layer, and the services layer. So we talked in previous sessions about the importance of sitting down with the customer and understanding what they're trying to achieve with their job, what they're trying to do and use the network for. And that is the services layer. So that conversation dictates what kind of services you will give your customers. If they want an IP camera system or an IP surveillance system, then you have a surveillance system. If they want to have a control system in their house, then you have a control system as a service. If they want to have whole house audio, you can probably plug in a Sonos as a service. So this conversation with your customer will dictate what kind of services you have. And the type and the amount of services will dictate the shape, the form, and the level of switches that are your access switches and the number of them. So this is based on the services that you get from your end customer. You start to plan out your access switches. If I have PoE for surveillance, then I put a PoE switch. If I want some unmanaged switches for just TVs and Rokus, then I can put an unmanaged switch. And the number of ports, right? So I want it front-facing or rear-facing, I want an 8, 16, or 24 port. This conversation on services will tell you how many switches you need, what flavor of switches, and how many ports for each switch. Then the amount of access switches that will serve your services will dictate the amount of ports that you need on your core switch, because we recommend that you use one uplink between the access switch and the core switch. Then from the core switch, you always go to your router and then to your ISP. So from the ISP layer, really what we recommend when you can, which is the majority of the time, is whatever you get in from your ISP, if you cannot exchange that combo with your own modem, then at least put that combo from the ISP on bridge mode and disable Wi-Fi. So basically you want that ISP box to be a modem, either your modem ideally, but if you can't use your modem, then bridge it. I know there are some challenges with particularly Verizon Fios. We're working with some of our dealers, our beta sites, to address that, and hopefully we can have something for you guys in the next 2 or 3 weeks. But basically you want this to be a modem. If you can change the modem to be your own, Motorola Aeris has a lot of good products. If you are in a cable company or in an area with majority of cable, like here in Charlotte area, we use a lot of Time Warner cable. Make sure that you get a DOCSIS 3.1 modem, not a DOCSIS 3.0, because DOCSIS 3.1 will let your customers scale up into their services. So I'm getting in my apartment, I'm getting 300 megabit per second down, 30 up, because I have a DOCSIS 3.1. So that I negotiated a free upgrade basically. When you have the router, so you get a modem, or you bridge the modem combo and disable Wi-Fi, and now you need to plug in the router, and hopefully it's our router, our 300 series router. And this topology, when you have a router connected on one link down to the switch, is called router on a stick. This is a very common topology for routers in branches or in SOHOs, we call small office home offices. And it's very effective because now you are basically using the router just to route traffic from the LAN to the WAN. While we have LAN ports on the router, we really don't recommend using those ports to connect other switches. Maybe you have a NAS drive that serves the whole network. Maybe you put that NAS drive there in the router, but basically use one link between the router and the switch. Now your core switch is very important. So your core switch is going to handle most of the traffic going from LAN to LAN. And that's when we recommend using managed non-PoE core switch. Number of ports is depending on how many access switches you need. You can squish the access layer and the core layer into one switch if you have a really small job, But if you have a mid-sized to a large job, then you definitely need a core switch to handle that traffic. So a managed non-PoE switch will give you a lot of visibility. It will give you a lot of control, and you'll be able to troubleshoot more effectively in case things happen in the future. So that's why we recommend using a managed non-PoE instead of an unmanaged switch. And again, access switches can be managed or unmanaged plus, what we'll talk about in a minute, can be PoE versus non-PoE, and this is completely dependent on what kind of services that you get from your customers. All right. So this is the recommended topology. Now we talk about different, global, kind of tips and tricks on how to plan and deploy your network. So these are, things that we saw in the field and, notes that we got from our tech support talking to you guys. First and foremost, use static IP addresses for all your devices. So all the devices that you are in control, not client devices, not your iPhones, not your iPads, that use your static IPs. Then even though we have DHCP reservation, some dealers like DHCP reservation, we really recommend using static IP. This way you can create your map of IP addresses, you create your schema, and scale that and deploy that on every single job. So say, okay, I want my router to be .1 or .10. Every single job, you know that your router is .10. If you want your surveillance or your surveillance system starting from .30, then every single job you know the first IP camera will be .30, so on and so forth. The second one is going to be when you do port forwarding, match your port numbers to IP addresses. This is a really good practice just for you to know what port number you're going to, what IP camera you're going to. So when you do, for example, if I'm trying to forward port to 192.168.1.20, use the last two octets in your IP address as the last two digits in your port number. So use port 8020. In that case, I have 192.168.1.25, use port 8025. And this way now you can match the ports on the external, on the WAN IP with the IP address, and you don't have, even though you have DDNS or you have some other kind of remote access mechanisms like VPNs, in case you want to use port forwarding rules, it's easier to remember and to document. The third best practice is color coding. It's very important. You can buy multiple colors of your patch cables or your bulk wire cables. Just do your color coding on your patch cables. Make sure that come up with your own scheme, come up with your own organizing agenda, and say, okay, maybe I want to use white color for all my uplinks between switches. I want to use red for all the surveillance devices. I want to use blue for all my control devices. I want to use green for everything else. And really, there's no best practice. There's no recommendation. You create your own color scheme and follow it day in, day out. We offer multiple color packages with our patch cables. Plenty of vendors do the same. To see how many color options you have, and just create your own scheme. And finally, you guys got tired of me saying this, documentation is super important. Once you design your network topology, put it in your documentation. Once you have your static IP addresses in your table, put it in the documentation. We have actually on the support tab, you have a document, Excel document that we created for you guys. Just a general recommendation, but you don't have to follow it to the same document. You can create your own documents and make sure that you follow it day in, day out and capture all the notes. So these are the general, network design and network practices that we would like to recommend, and I'm pretty sure that you guys are asking lots of great questions that we will address towards the end of the session. So let's move on to VLANs. What are VLANs? So a lot of our dealers ask us about VLANs and how can we use them, when can we use them. VLANs, to begin with, they are part of a standard. So everything in networking, almost everything in networking, is part of IEEE 802 group. So 802.1q standard defines VLANs or VLAN tagging specifically. What VLANs do, they create a logically separated networks, and that logic can span multiple switches. So while you have a physical topology, you might have a different logical topology, and that can be enabled by VLANs. So basically, you can think of VLANs, and VLANs allow you to think about your network in a different manner. Basically, you can think about it as total number of ports and how would you allocate those ports differently or separate them in a different logical manner. VLANs, they have multiple types of VLANs, so you can do port-based VLANs, which is the most common we will cover today. You can do MAC-based or you can do protocol-based. All those types we support, but really port-based VLANs or VLAN tagging is the most popular by far. The question that we get from dealers is like, when do I need VLANs? And the quick answer is that you definitely do not need VLANs for smaller jobs. If you don't have, as a rule of thumb, if you have probably 15 to 20 IP cameras with lots of control systems and whole house audio, then we'll probably start thinking about VLANs. If you have a small job with 10 to 20 devices and 4 IP cameras and a couple of access points and one touch panel for a control system, you probably do not need a VLAN. So it's all VLAN is a solution to a problem, and the problem being you have a lot of chatty devices on the network. So your surveillance system, your NVR with IP cameras, they send a lot of traffic between each other. So that's a chatty system. Your control system between touch panels and the controller and other devices that the control is controlling over the IP network is also sending a lot of multicast or broadcast traffic. So that's a chatty system. Once that system scales to a size, then you need to isolate that chatter into its own VLAN. And you definitely can't create too many VLANs. So we've seen dealers calling us with 6, 7, 8, 10 VLANs. And that's just, just too much. If you're planning your job and you start seeing more than 3 to 4 VLANs, you probably need to rethink about your VLAN isolation and how you want to segment or logically group those different devices or services. VLANs, as you will see now in a minute, they are a solution to a problem, but they also don't come free of charge. They add headers, they add overhead to your traffic, and they change the flow of traffic across the network. But they can solve big problems. So they can enhance your network performance when you don't have VLANs and you have a lot of chatty devices. Then you end up with a really slow network. And they basically segment the network into what we call separate broadcast domains. So all the broadcasts are isolated within one VLAN and will not bleed over to the other VLAN. Some design methodologies, especially we see it on commercial IT space, is that you use VLANs to enhance security controls. So if you say I want to have, if you have a restaurant and you say, okay, I want to have a tenant's network and an employee's network, and those two networks will not talk to each other, then VLANs is one way to enhance that security and enforce that policy. And like we said, it allows for logical grouping of network devices. So let's walk through an example of how, if you want to set up a VLAN. So let's say we got this great topology that we created, and we quickly realized that we have 20 IP cameras here, and we want to isolate all surveillance traffic within a VLAN and everything else with another VLAN. So we have 2 VLANs we're trying to create. So what are the steps that we need to do in order to create that VLAN? So step 1, we create VLAN. Let's call it VLAN 10. Give it an ID. It's a number from 1 to 4,000. So you create that VLAN. In this case, we give it an ID of 10 on that switch, access switch. And we assign the ports that are connected to the surveillance system to VLAN 10. So that we have 2 types of ports. We have an access port and a trunk port. The access port basically carries 1 VLAN. The trunk port carries multiple VLANs. That's a simple distinction between the 2. So with that being said, we say, okay, we want all those ports on the on that switch or connected to the surveillance system to be part of VLAN 10. Step 2 is to add VLAN 10 to the uplink from the access switch to the core switch. So that makes the uplink as a trunk port, because it will probably create a VLAN 10 and a VLAN 1. Then create VLAN 10 on the core switch and also on the uplink from the core switch to the router. And finally create VLAN 10 on the router and create a subnet for that VLAN. So once you follow this path, now your VLAN 10 is created and it's extended all the way to the router. Now, you might want to say, I just want this surveillance VLAN to be isolated within that switch, and it will not be talking to anything outside that switch, or nothing outside that switch will be talking to that VLAN. Then step 1 basically is enough for you. All you have to do is create that VLAN to that switch and assign those port numbers to that to those devices, to that VLAN, and you'll be good to go. But this case, we say, okay, we want, and what we did when we extended the network all the way to the router, now we created, 2 separate isolated VLANs, and once you create the subnet on the router, now this VLAN can reach the internet. So in our case, which is another good practice, is to match the 3rd octet of your IP addressing schema with your VLAN ID. So if I have VLAN 20, will be 192.168.20.x. If I have VLAN 100, then 192.168.100.x. There is no priority in the VLAN numbers. It's just an arbitrary number that you can pick from 1 to 4,000. So in our case here, we have a subnet that was created on the router, and 192.168.10.1 on the router is the gateway for all devices on that subnet, which is also a VLAN 10. And also a very good practice is to match subnets with VLANs. So if you want to create a VLAN, give it its own subnet, and don't span the one subnet across multiple VLANs. It's just a best practice. Now, once we extended the VLANs and the subnetting all the way to the router, now I have control on the router to enable inter-VLAN routing. So if I want VLAN 1 to talk to VLAN 10 and VLAN 10 to talk to VLAN 1, I have that control all in the router. And that's called inter-VLAN routing. So you see now, even though they are physically connected into one topology, logically, traffic going from VLAN 10 to VLAN 1 has to go from the access switch to the core switch, to the router, back to the core switch, to the access switch. So that's why you need to be careful about the number of VLANs you create and what kind of overhead you're adding to that VLAN. With that being said, let's run through a quick setup demo on our new line switches, which we'll introduce later in the session. But I want to show you guys how easy it is to create VLANs in our switches. So this is an 8 PoE, a 210 8 PoE switch that we released 3 weeks ago. And if you want to create VLANs, basically you go to under settings, there's a VLAN section. And I'll add a VLAN. So say, okay, the VLAN ID, I want to say it's 20, and give it name as surveillance. And you have 2 main columns you need to pick from. So there's access ports and there's trunk ports. Remember that access port is a port that carries only 1 VLAN. That trunk port carries multiple VLANs. So let's say in our case, just click on this empty box, and we have a little pop-up window here that says, okay, these are the port numbers that we have on the switch. That includes the SFP numbers and also the link aggregation groups. And do you want it to be an access port or a trunk port? So let's say in our example, I want port number 2, 3, 4, 5 as part of this VLAN as an access port. So these ports are connected to, let's say, an IP camera. And then the trunk port, which is the uplink between my switch and the core switch. So I click on trunk and say, okay, port number 1 in my design is always the uplink between switches. So I use this as a trunk, just confirm, hit apply, and now I created VLAN 20 and assigned ports 2 to 5 to VLAN 20, and now I have that VLAN extended to port number 1 to the core switch. Now, second step, I have to go to the core switch. So in this case, we have a 310 16 non-PoE switch. And I can go to VLANs, I need to create the same VLAN, right? So we already have a VLAN 10 created. I can add a new one, give it the same ID, which is VLAN 20. The name is really arbitrary, so we can make it the same as a best practice. And the access port or the trunk port in this case, because we have, if it's a trunk port on the switch coming on the uplink, you need to create as a trunk port on the access switch or the core switch as well. If all the traffic coming from the access switch is only VLAN 20, then the uplink can be only an access port, and the port connected to it is an access. But in this case, the trunk port on the access switch is carrying both VLAN 20 and VLAN 1. So we'll go back and say, okay, this port, let's say it's port number 5, is a trunk port, and in our schema, port number 1 is connected to the router. So I hit confirm, hit apply. Now I extended the VLAN from the access switch to the core switch and to the uplink going to the router. So our routers, our 300 series router, supports VLAN and supports inter-VLAN routing. So I can go under advanced VLANs. You can see we already have VLAN 10 created here. I create a new VLAN, give it the same ID, which is 20. Best practice to give it the same name, it's just surveillance. And really, if all you have to do is change the LAN port that is connected to the core switch to be tagged. Let's say it's connected to LAN port number 1, and then hit apply and save. So the cool thing about the router is that since we have now 3 VLANs, you can see there's a column says inter-VLAN routing. So inter-VLAN routing in our setup here is enabled between VLAN 1 and 10 that we already created. So VLAN 1 can talk to VLAN 10 and VLAN 10 can talk to VLAN 1, but it's disabled on VLAN 20. So those 2 VLANs cannot talk to VLAN 20 and the VLAN 20 cannot talk to VLAN 1 or to those VLANs. The other cool thing is that you can enable or disable device management. So this is telling the VLAN if those clients on those and that VLAN and that subnet can access the web interface of the router. So that's another security measure that you can add to your VLAN setup. You can say, okay, only one VLAN can access the web interface of the router. All other VLANs will not be able to. The really powerful feature is route binding. So this is basically when you have a dual WAN situation, you can create a VLAN and route all that traffic from that VLAN to only one of the WAN ports, not the other. So in our case, if we want surveillance to be accessed on WAN 2 only, so we can click on WAN 2 and click apply, then all traffic going from WAN 2 surveillance is going through WAN 2. It will, when WAN 2 goes down, they will not back up because it's forced to WAN 2. If you take it none, then it's going to follow the dual WAN rules that you have, either load balancing or link failover. So that's basically it. So it's creating the VLAN is really not that hard. It's just designing it and taking the consideration into what part of VLAN, how many VLANs you need, and how you want to extend it across the board. And like we said here, it has to follow, it's an end-to-end solution, it has to follow the path of the traffic that you're trying to achieve. If you want the VLAN to be only isolated to the core switch, then you only extend it to the core switch. If you want to have it reach the internet, then you need to extend it all the way to the router. Just to keep that in mind. All right, so we're a little bit behind on time, so I'm trying to go to another even more complicated topic, which is spanning tree protocol and Sonos. So we've heard a lot about Sonos and what kind of challenges that you guys have deploying multiple Sonos devices in your network, and what kind of headaches that you guys are running into with Sonos. To understand the underlying problem or challenge with Sonos devices, we need to understand the underlying technology. So the underlying technology is called spanning tree protocol. And spanning tree protocol basically is a protocol that is designed to avoid network loops in your design. And network loops are bad because they create something called a broadcast storm. So if you'll see here on the left side, we got 3 clients, A, B, and C, connected to 3 switches. And in normal traffic, client A, if client A is sending to client B, then it goes down to that switch, and then to the other switch, and goes to client B. If client A wants to client C, then it goes down the switch, to the other switch, and then to client C. That's a normal traffic. But let's say, I made a mistake and just connected both switches because I thought that I'm doing more redundancy. So what happens is when client A sends a message to client B, you have two paths. You have a path that goes through the left switch and the path that goes to the right switch. So the left switch sees that there's a path going to client B directly, so it sends a copy here, and then a copy back to the right switch, because the right switch is seeing a path towards client B. Then client C, the right switch, it will send two copies, one back to the switch and the other one to the other switch. And now we have multiplications of redundant copies of the same message being sent around the network, and we'll create what we call a broadcast storm. So that's basically a broadcast message that's being created across the network. And you might think that this is taking too much time, but this is the explanation of it. It happens in milliseconds, and you end up with a network that is virtually unusable. I mean, I told the guys here we have an example in past life when we had a campus network with 100 plus switches in the network, and there was a broadcast storm, there was a loop in the network, and within 6 seconds nothing on the network would operate. All the VoIP systems were down, all the servers were down. We were actually on a server trying to do something, and we cannot even move the mouse on the server because the network card is eating up all the memory on the server. So broadcast storms are really, really damaging to your network, and they create excess of packets on your network that can damage ports, and you can see some switch ports failing because they cannot handle broadcast storms. So how does spanning tree work? Let's go back to our topology when you have a really simple 3 switches and 3 clients. So the good news about spanning tree is that it works automatically in the background. You do not have to interfere with it. The bad news is that in case of Sonos, you need to interfere with it to make sure that it's working well. So let's explain how spanning tree works. So basically, the switches go through an election process. Part of the protocol of the algorithm, they have some algorithm, they elect something called the root bridge. And the root bridge is the core switch, or the switch that handles all traffic. And let's say here we have, the switches communicate among each other, and they elected the left switch here to be the root bridge. So by definition, the other 2 switches are non-root bridges. And now spanning tree defines that every port on the root bridge is forwarding traffic. So it's in a forwarding state because it's a root bridge, so it has to handle all the traffic. Everything has to go through it. And then for non-root bridges, the ports that have the least cost to the root bridge are in forwarding state. Directly connected to the root bridge is the least path cost, and then when you add links, then you add a number or parameter that determines what's the cost to that root bridge. So in our case, because they're directly connected, those ports are directly connected on non-root bridges. They're called root ports. So a root port is the least path cost to the root bridge on a non-root bridge. And by definition, a root port is in forwarding state. So that port forwards traffic. Then you end up with 2 ports on those 2 switches, and these are non-root ports on non-root bridges. And those non-root ports on non-root bridges are in blocking states. So this is when spanning tree blocks traffic on that port or those 2 ports. And that's important to understand because the physically those 2 ports are connected, but there's no traffic going through them because spanning tree is blocking this. And because spanning tree is blocking this traffic automatically, now if client A wants to go to client B, then we'll follow this path. Client A wants to go to client C, we'll follow the other path, and there's no loop, and there's no broadcast storm. Now, why is Sonos causing us or causing you guys so much headache? Sonos adds a wireless link or wireless mesh between the 2 Sonos devices because they want to make it very easy to install and very easy to set up. So if you follow the same design that we've had in our good 3-pronged topology, and we added Sonos and on each side of the switches, and we have a wireless link established between those 2 Sonos devices, then we have a loop. So to solve that problem, Sonos said that, okay, we need to make sure that our devices are part of spanning tree negotiations to avoid any loop. And hopefully that the wireless link will be disabled part of spanning tree. But that's not the case. Sometimes let's assume that the same negotiation happened and the same root bridges were elected and the same port blocking happened, then you end up with this kind of scenario when if I want to send traffic from client A to client C, I have to go over the wireless link between two Sonos devices in order to get to client C, and that's client A and client B. That wireless link is on 2.4 gigahertz. It's very, very slow. It's only meant for streaming audio, which is very low traffic overhead, but not meant for normal traffic. So what you end up seeing in the network is now you have a very slow network. You think it's a broadcast terminal, it is not. This is spanning tree working the way it should work, but traffic is going over the wireless link. And that is the underlying problem with how to connect multiple Sonos devices in the network. So best practices, how can we solve this issue? How can we avoid this issue? And these are recommendations that we actually saw in the field and tested in our lab, obviously, and we recommend those practices that you follow, and obviously you contact your Sonos support to make sure that everything is kosher on that end. So best practice number one, if possible, connect all Sonos devices to one switch. You will eliminate a lot of the unwanted loops if you do that. Sometimes it is not possible because the way the Sonos devices are spread out across your network, but if it is possible, as you design, put your Sonos device on one switch. On top of that, best practice number two, because your core switch is a managed switch, I can show you in a minute, how can you go and change the election process to force the core switch to be your root bridge. And this way now you're forcing all the traffic to go through the core switch, not through any other switch. So you eliminate the possibility of having a wireless link being enabled and one of the other ports being blocked. Best practice number three is if you have few zones in your house or in your setup, a hub and spoke topologies for Sonos is recommended, and that's something that actually Sonos highly recommends. Is you keep one of your Sonos Connects hardwired to the switch, and have everything else Wi-Fi to that one Sonos. It is, audio streaming. It's really not high bandwidth. It can sustain over the wireless mesh. So that's, if you call tech support from Sonos, they will recommend this topology. But this is not scalable topology. This topology only serves you, I think, between 5 and 8 zones, maybe 9. But we've seen dealers who have 15 to 20 Sonos zones and jobs. So that comes to a really complicated topology that we recommend when you do this, when you have a really complicated topology, is to hardwire Sonos devices to switches as much as possible. Keep one Sonos device hardwired and the others Wi-Fi for those devices on Sonos that do not have a RJ45 on the back and completely Wi-Fi. And disable Wi-Fi on those Sonos Connects. Now, unfortunately, this is something that we found in the field, that we've tested. We know that it works. If you disable Wi-Fi on Sonos, Sonos will not support you very well. They will tell you that you need to enable Wi-Fi before you will support us. So that's something, that's a conflict that you need to be aware of when you have a call with Sonos. Best practice number 5, there is a hidden web interface. It's a web interface on each Sonos Connect, I think. There's a really great article here that you can get. We will send it as part of the follow-up to the webinar. We'll highlight all the steps and all the different options that you can find within the hidden page. It's a really valuable tool. One of the greatest things that you can find in this hidden web page is that it tells you, it gives you a map of the number of units and what's their spanning tree state. Is it forwarding state and STP state, or is it the blocking state, and what's the signal level between different Sonos in the neighborhood. So it's a really powerful tool. Highly recommend that you read this article. It's fairly technical, fairly down to the weeds, but it will give you a lot of troubleshooting tools. Now I'll show you how can you change, like I said on best practice number 2, how can I change the bridge, how can I force a switch to be a root bridge. So going back to our core switch here in our example, so say we have a 310/16 non-PoE. I go to advanced, I go to STP, go to global settings. Oops, I'm locked out. So go to Advanced, STP, Global Settings. Then you can see under Basic Settings here, there's priority. By default, all the priorities are 32K, 32768. You can change this to the lower the number, the higher the priority. And basically, this is part of the election process. If you have a high priority in your election process, now this is your root bridge. So my core switch, I changed it to 4096, hit apply. Now, during span tree negotiation, I'm guaranteed that this switch will be a root bridge. It's fairly simple, very, very easy. So that's Sonos. Other things that we found in the field is ubiquity access points, especially when you talk about PoE switches and ubiquity access points. Basically, ubiquity has two, we'll call it quote-unquote tiers of access points. They have their own proprietary passive PoE, which runs on 24 volts, and they have a dual mode model. So you see the models that UAP, UAP-LR, UAP-AC Lite, and UAP-AC-LR. These are all passive PoE, proprietary non-standard PoE. And UAP Pro, AC, AC Pro, and AC EDU, they can support 802.3 AF and AT, and this is what every single switch in the market other than Ubiquiti supports. So we support 802.3 AF and AT in our switches, and we highly recommend using those devices. If you have any of those non-standard PoE, then either you buy a Ubiquiti switch or you use the PoE injector that comes with the product to connect to our access point. If you have a Ubiquiti switch, you want to connect to our switch, highly recommend using the SFP on the Ubiquiti switch if possible, and use the SFP on our switch as well. Because their switches are not standard, they're dual modes. There's a lot of uncertainty and unpredictability with this design, and we highly recommend not using non-standards. So if you are forced to use a Ubiquiti switch, use an SFP port to connect the two switches. The last thing before we go into the introduction of our new line is URC. So URC, they have, if you're a URC dealer, you have something called MFS switch that you can buy from URC. And basically they recommend using that switch because they have something called MAC filtering. Actually, it's not MAC filtering, it's multicast IP filtering. So we worked with URC to understand what they're doing in their switches and how can we make it easier for you guys. So long story short, if you are a URC dealer, you have to buy a MFS switch for each 8 URC devices, and basically it isolates those URC devices from the rest of your network because they want to filter some multicast IPs going into and out of the switch. The problem with an MFS 8 is fast Ethernet interfaces, and it's only 8 ports, so it doesn't scale, and it's an extra cost to the system. So you already have switches, and now you have URC total control, and you will find out that you need to buy this extra $200 switch. So we worked with URC very closely, and I believe that we are the only vendor in the market that worked with URC to that level. And we included a support for URC on our new 210 and 310 switches. If you have a 300 series switch, call our tech support. They can help you set it up through IGMP snooping. But in the new line of switches, we made it super easy. So let's say if I have a 16-port or core switch, let's go ahead and have an access port here. I have a URC set up. So I can go to Advanced, go to Multicast, and click on IGMP snooping. Well, I'm logged out again. Session timeout. So go Advanced, Multicast, IGMP snooping. And at the bottom of the page, you can see there's URC settings. So that's the section that we created. Don't think that there's any other switch in the market like this. You enable it, enable that the state, and you click member ports. So literally just click on the ports that are part of URC. These are URC ports. Hit confirm, they're part of VLAN 1 or what VLAN ID that you created. Hit apply, and then you're done. No crazy IGMP settings. You don't have to buy extra switch. We made it super, super easy for you guys. All right, so we are probably 10 minutes away, so I want to fly through the rest of the presentation just to get to some of your questions. If you haven't noticed already, we have a new line of switches. So 100 series and the 300 series have been in the market for over 2 years. The 100 series being unmanaged, 300 being managed, a managed PoE. Great success, very popular, been growing like crazy. We very much appreciate the support, but I think it's coming time to refresh the line and up the standards a little bit. So this is the new line of switches. So 110 series launched about a month ago will replace the 100 series. The 310 series will be launching early June, will replace the 300 series. And we introduced a couple of weeks ago a completely new line of 210 series. So 110 series being unmanaged plus, I'll explain what that means in a minute. They have 5 A1624 port. 210 series is Web Smart. I'll explain that in a minute. It has gigabit partial PoE. A1624 port in the market, 48 port coming soon. 310 series is fully managed layer 2 gigabit non-PoE and full PoE. A1624 port will have 48 ports soon as well. Some features that when we went into design of this whole family, we tried to make the new family very, very aesthetically pleasing for your racks. We know that you guys need to show off your work, show off your products, show the customers their investments. So we try to make those switches, the rear port version, as AV as possible. So the first thing that you'll notice that there are blue LEDs on the front, and you have this shiny, glossy faceplate. We have the power LED that is blue. It's a fading blue as well. Because we have the power LED all the way to the left, we justified everything to the left. So if you have a smaller switch, you find that there's a smaller rack ear and a longer rack ear. And that's because when you stack multiple switches, like here in the picture, it makes total sense to have everything justified to the left, not centered. So the switches, you'll notice, will be off-centered, but we're working on an accessory for rack ear if you want to have them fully centered. You can buy them separately. The second thing that we got from you guys as part of your feedback is that the 300 series switches and the 100 series switches in the market, when I plug in a port or a cable to the port, I cannot see what's going on. I have to go to the front of the switch. So why don't we add LEDs on the RJ45s? We did that in the new line. So that's something that we added based on your feedback. We appreciate it. And you can see there's a really cool honeycomb side vent that we have for ventilation. The other thing that you see in the PoE models in terms of fans, we went for 300 series, those were multiple or variable speed fans that were controlled by wattage, so how much watts is the switch supplying controls what speed of fans. We recognize that this is not the most efficient way to do it, so with the new line switches, we have temperature controlled speed fans. So there's a thermal sensor in each switch that drives the speed of the fan, so this way we're actually providing the optimal ventilation and heat dissipation for the switch, and while keep it variable and as quiet as possible. Mounting options are still the same. As you can see, this is what I explained when you have an off-centered switch design, because we want to align everything to the left. So multi-mounting option will still provide you with front, rear mounting option. You can have them recessed, you can have them flush. It gives you a lot of versatility. Now with PoE, now we have two series of PoE. There's 210 PoE and 310 PoE. The only difference between the two is really the power budget. 210 being partial PoE, it has, sorry, it has PoE on all the ports. So all the ports support PoE and PoE+. So each port can go up to 30 watts. But basically the pool of PoE is half on 210 than it is on 310. So take an example here on the screen. If you have an 8 PoE, if you have a 210 8 PoE, you have 65 watts total power that you can deliver up to 8 watts simultaneously on all ports. But one port can go up to 30 watts, which means you have only 35 watts for the rest of the ports. If you have a 310 8 PoE, it has 130 watts total pool that can give you 15 watts on all ports simultaneously. So that's really the only difference between 210 and 310. So talking to the families, so 110 series is unmanaged plus. So that's a completely new concept. We are the pioneers of this concept in the market. Unmanaged plus basically is an unmanaged switch that is overseas enabled. Why should you care? With unmanaged switches, you really have no visibility to what's connected to that switch. Once you plug in an unmanaged switch, like a little 5-port behind the TV, and you plug in Apple TVs and Roku's and other devices, a WAP box to it, if anything happens to any of those devices, you really don't know what happened to that switch. Is it the device problem? Is it the port problem? Is it the uplink problem between the switch and the core switch? You really don't know. With Unmanaged Plus, we extended that control or that visibility to the edge of the network, all the way to your access switches. So even the 5-port that you have, you put it behind the TV, you can see it on overseas, and you can name the ports, and you can see a lot of cool things that I'll show you in a minute. It still has metal housing across the board, 1U for all the products except for the 5-port. It's a compact design. It's full gigabit across the board, and it's fanless because no PoE. Now 210 series is a web smart switch, so what that means is really a managed switch minus some advanced settings that a lot of dealers don't really care about. But we are working on a firmware update to make the 210 series fully managed as well. It has metal housing, it's full 1 gig, it's plug and play, it's partial PoE, PoE plus, we explained in a minute, back in a minute. But the cool thing about the 210 is now, because of a lower power budget, the 8 PoE of 210 is fanless. We do not need a fan to dissipate the heat from that unit. So that's very, very interesting, because now you have an 8 PoE model that's completely silent. And then 1624 PoE, they have the variable speed fans we talked about. 310 is a complete replacement of the 300, so nothing new outside aesthetics and great quality. It's layer 2 managed, it's metal housing, it has full PoE and non-PoE options. So with that being said, I'll give you, I got a couple of minutes probably to give you a quick demo. So the interface that you go log into a 210 or a 310, it's really not anything different. You saw it in our demo before. Arachnus is your basic login. You have to be aware that everything now is DHCP out of the box. There's no fixed IP address. And then it follows the same layout as we have before. So we get everything on the left navigation. We added here in the switches a cool thing that you can search. So if I have a feature that to say, okay, I want to see IGMP, that gives you multicast IGMP snooping, and if I click on it, I'll jump immediately to the IGMP snooping page, so I don't have to navigate through it. But it's a really powerful product, has all the bells and whistles, all the features that you need for your job under control. The last minute I want to spend here is on overseas. So I want to quickly show you what kind of features you get on switches across the board with overseas. So this is our demo account for overseas. I have let me find that, a managed plus switch. So we talked about a managed plus. So this is a 5-port. This is a 110 5-port switch, a managed plus. So imagine this switch being in the back of the TV, and you can see it now is online or offline. You can see the system uptime, and you can see the port information on that switch. So if I have this port is connected to, this is my uplink, connected to the internet, I can see it's named internet, it's gigabit, it's full duplex. I can click on the info button. I can see some port stats, data sent, errors sent, data received, errors received. This is an unmanaged switch. So this is a very, very powerful switch. I can go to configure. It has an IP address, so it's DHCP out of the box. I can change it to a static IP from overseas. I can change my port configuration. I can see we named the ports: Roku, Samsung Smart TV, link speed. I can force link speed. I can disable a port if I want to. I can reboot the switch completely. Super powerful. This is the greatest value that you can find in any unmanaged solution. There's nothing like it in the market. We'll go back to the demo account. In the last minute, I show you a 210 switch. It's basically the same experience that you have on the current 300 series switches. So go back to our jobs, got a 210, 8 PoE switch here. So basically, you got the same thing that you got on 300 series switches. It's online, offline, the PoE power budget utilization. This is very important for 210 to see if you're reaching your limit or not. Snapshot of your ports. You have two SFP ports on 210 as well as a 310. And then you can power cycle individual PoE ports. I can shut off PoE or turn it on. I can see my consumption per port. It's very, very, very powerful feature set. All right, with that being said, I think I reached the extent of my welcome. I will give it to Heidi for some quick Q&A.
All right, thanks, Aham. That was great. We are about out of time, but let's try and squeeze in a few questions here. We've had a lot of great ones come in. And just as a reminder, you can submit your questions through the question and answer feature in the webinar control panel. Okay, first question. Let's see, are you still offering front and rear port versions of the switches?
Yes. So what you will see is the rear version coming in the market now. And then the front versions will probably hit in late June, July timeframe. So you'll see the front versions of the 110, 210, and 310. So we will replace that as well. And also just following to Heidi's comment on questions, we read all the questions and we will send you answers to all your questions if we can't cover them now.
All right. Since the 210 line is only WebSmart and not fully managed, can you still set up VLANs with that 210 line?
Yes, absolutely. So basically between WebSmart and Manage, it's very minute difference. You'll see something like MLD snooping, not having access control lists on the switch is the difference. But you can do the basic settings, VLANs, IGMP snooping, spanning tree protocol, naming ports, doing PoE. You can see all of that on the 210 and the 310.
Okay, does the STP or spanning tree protocol rule only apply to Sonos, or is that a common rule for all music streamers such as Denon and Autonomics, Mirage, even Apple TV?
That's a great question. It really depends on how those devices operate. If there's a wireless link that's happening in the background automatically between those devices, then the same problem happens. I don't think that Apple TVs have a wireless link automatically established. They have some Wi-Fi that connects to the network, but they don't automatically mesh. Sonos, they have automatic mesh. I'm not too familiar with what Denon EOS is using, but maybe they're using the same thing. So if you find the same issues with your streaming devices, then the same problem will happen with Smack.
Communication between 1 and 20, but don't let 20 talk to 10.
All right, so the question is, with VLANs, can we isolate the communication between VLAN 1 and 20 and not have 20 talk to 10? Yes, so that's when inter-VLAN routing happens. So that's when it's powerful to have VLAN capabilities on your router, because once you extend all the VLANs all the way to the router, you have the control on the router to allow inter-VLAN routing between one or the other. Now, you might want to say, okay, I have inter-VLAN, I want 1 and 20 to talk, 1 and 10 to talk, but 10 and 20 not be able to talk. Inter-VLAN routing will not help you there. This is where access control lists will help you. So we can probably do another session about access control lists because it's a very also deep topic.
All right, and we're over time now, so this will be the last question. A router-specific question. Is there a way to include the devices with IP reservations in the list of online devices? So having everything in a single window would be more useful.
That is something that we're working on in a firmware update. So the client list on the router currently is the DHCP client list, but we want to add the static IPs to the client list as well. But if you have a DHCP reserved device, then it will be part of the client list today because you can see it as part of the client list and you can do reservation with one click from the client list.
All right, and our time is up, but like Aham said, we do have a list of all the questions you submitted, and we will get back to you with answers for those. And before we sign off, I want to remind you to look for the follow-up email that's going to go out within the next couple of days. That will contain a link to today's presentation, along with a coupon code for $50 off your next Arachnus Switch purchase. And lastly, we'd like to ask that as you're exiting the webinar to please take a minute to fill out our 3-question survey to let us know what you thought about today's presentation. And thanks again for taking the time to join us. We hope you have a great day and see you next time.